Hello everybody and welcome to Pisa Presents. Today we're going to be looking at gypsum, the mineral that builds our world. And what a lovely world it is too as we look over the view of the gypsum dunes of White Sands National Park in New Mexico. First of all, you may be asking yourself, well, what is gypsum really? Its formula is CaSO4 2H2O, or it's also known as calcium sulfate dihydrate. Now, that hydrogen is very important to gypsum and us, as we'll see soon. Today, gypsum's used mostly in construction, drywalls up to 90% gypsum, for example. It's also used in plasters and cement, as a soil conditioner, and as in cosmetics, medicine, and even food as a major ingredient in many meat-free products. It's also used in brewing and as an anti-caking agent in yeast and thusly many baked goods. Altogether, gypsum's been used by mankind for upwards of 7,000 years, with a common use being in ornamentation or statuary. This here is Lamasu, which is a guardian deity from the Middle East. Why is it used so much in statuary? Well, it's soft and abundant to find, and it's just very easily workable. So gypsum is mostly an evaporite. It can form in different ways. So an evaporite is a sedimentary rock composed primarily of minerals produced from just that, evaporation. Now, this is an absolutely stunning picture. This right here is gypsum crystals from the Cave of the Crystals in Mexico. And these here are up to 37.4 feet long in this location, which is just absolutely amazing. And to give you an idea of scale, in case you can't see our spelunker friend in the corner, here's a little something for scale for them. Now, some characteristics of gypsum. It most likely gets its name from its most famous relation, which is gypsos, meaning plaster. Gypsum's long been used as an ingredient in plaster. It's also the most common sulfate mineral. It has its own division on the Mohs hardness scale, right here. So those hydrogen bonds that we mentioned earlier, well, they're very, very weak. And say that you would start heating that, well, they would break down, and it would actually cause the gypsum to turn into another mineral, basanite. And then if you keep heating that, it turns into yet another mineral, anhydrite. And, well, just say for devil's advocate, if you really felt like going all the way, you started getting that wet, well, you can rehydrate it into gypsum. But just so you know, if you do that, it actually causes the volume of anhydrite to increase by half. It has monoclinic crystals, which is where all three axes are of an equal length and two of them are perpendicular. Its crystals are usually colorless to white. I say usually because look at that color right there, that very, very pretty coppery orange. Also too, this very, very nice apple green that's right here. Both of these specimens are from Australia. And there were up to 5 basic forms of gypsum. So the first and probably the most famous is alabaster, which is fine-grained and translucent white. Now, a little note, just so that you know if you look this up and you see things in various sources, you'll see in a lot of archaeology texts, also more so, that people refer to fine-grained calcite as alabaster too. In mineralogical sources, alabaster is fine-grained and translucent white gypsum. Not really calcite, but just to let you know in advance, you may see the term used for both. Gypsite is a very soft, perhaps 1.5 on the Mohs scale, impure form of gypsum, and some folks count it within another variety. Others classify it as separately. Now, rock or just plain gypsum, so just calling it gypsum, period, is a name some give to the natural underground deposits, like Carlsbad Caverns is in part a gypsum cave and is a place I want to see so darn much. Satin spar is parallel fibrous gypsum. Selenite is the term given to transparent crystals, and just so that you can see what gypsum looks like under fluorescent conditions, well, that right there in the bottom middle is it under visible light. And then shortwave UV is the specimen in the upper left. Gypsum has very, very characteristic, like a blue, a cerulean blue, under UV. And then long wave is in the second row left. It's also known for its phosphorescence. So short wave phosphorescent is in the upper right, and long wave phosphorescent is basically in the middle on the right, that green color. This here is a twinned crystal. It has a form that's known as the Roman sword. Twined, sorry, not twinned. This is a very, very famous form that gypsum can take. It's actually called a desert rose. So desert roses form in evaporite areas and wet mineral-rich sand. So if you can kind of think almost like how a pearl forms, 69 to 70% of a gypsum rose is a desert rose is gypsum, with the innermost parts having more silicon. So the idea is that you have like a little itty bitty grain of silicon somewheres, and the gypsum builds upon it in layers. So instead of forming concentric layers like a pearl, it branches out into these very, very pretty, just, it actually does in many ways, it looks like a flower. So they're called desert roses. It can take other forms like this right here, the ram's horn. And about 16 U.S. states and 90 countries mine gypsum. In 2023, the U.S. produced 22 million metric tons. We actually used a total of 43, so we do import quite a bit. The average new house contains 7 metric tons of gypsum, mostly, again, as drywall. And that is because as gypsum conducts heat poorly, it's used very commonly in the sheetrock. Now, this right here is actually a historic map. It's from Ohio. Just to give you an idea that while gypsum is found in many places locally, like say in Pennsylvania, the C.K. Williams Quarry, this can perhaps give you a hint as to how widespread it can be. So with that, we leave you to further mineral exploration on your own.